So in this problem here, the first thing we'll do is we're going to read that question sentence first. Remember, as always, the numbers don't matter until you know what to do with them. So here we go. The question reads, what is the total time? So when I highlight that, what is the total time? It seems to me that we're presented with times, right? I'm just looking at this and it's saying, hey, a soldier completes 3 timed tasks. We have task number 1 here at 4 minutes and 35 seconds. Then we have task number 2 at 3 minutes and 50 seconds. And then lastly, we have ourselves task 3 at 2 minutes and 45 seconds. So when we have these 3 activities or tasks, to get the total straight up, we're just going to go ahead and add these up. That's it. So let's go ahead and do that. We have, again, 4 minutes and 35 seconds. We also have 3 minutes and 50 seconds. And lastly, we have ourselves 2 minutes and 45 seconds. So we have all of these written down. And the easiest way to start, in my opinion, is going to be just adding up the minutes. Everybody, when we add up the 4, 3, and 2 together, what is that going to give us in terms of the number of minutes? Yeah, that's going to be 9. 4 plus 3 is 7. 7 plus 2, that is currently going to be 9 minutes. But be careful. Again, I said currently 9 minutes. Quick question, everybody. If it just so happens that we have more than 60 seconds when we add up all of these seconds here, is it true or false that this number of minutes will go up? Yeah, absolutely true. If we have more than 60 seconds here, we're going to have to go ahead and convert all of that excess, all of the groups of 60 that we can make, we got to turn it into those additional minutes. For the same reason that we don't say, hey, this is 1 minute and 105 seconds, right? What's the point of even saying the minutes if you're going to say a number of seconds that is way over 60? No point at all. So let's handle business here. I am going to take these 3 seconds over here, and I'm going to perform the total right now. We have 5 plus 5 and the 0 there. So that's going to make 10 with 1 being carried over. Then we have over here, 3 plus 5 is 8, plus 4 is 12. Bring that over, and that is 13. So we have 130 seconds. Everyone, how many minutes is 130 seconds? Yeah, that's 2 minutes. That is 2 minutes. If you can't see it right away, don't worry, because I got you. 130 is going to be 60, 60, and 10. So guess what? This is a minute, and this is a minute. So everybody, we have 2 extra minutes. We have 2 extra minutes here. So what does the 9 minute and 130 seconds become? It ends up becoming 11 minutes. So again, we take these 2. So that'll be 11 minutes. And then the extra 10 seconds. And there we are. That is the proper solution to this question here. 11 minutes and 10 seconds. If you chose D, that is just an improper way of saying it. The correct answer here again is answer choice B. 11 minutes and 10 seconds. All right, so next problem up. First thing we do, as always, we're going to read that question first. So it says at 12 p.m., how far apart are the 2 hikers? All right, so primarily speaking, what we want here is, again, how far apart are these 2 hikers? So to get this done, I'm going to just understand the story a little more. Because it says, hiker A leaves Pine Camp at 6 a.m., averaging 3 miles per hour. Hiker B leaves at 9 a.m., averaging 4 miles per hour in the same direction. At 12 p.m., how far apart are the 2 hikers? So it looks like we got a couple of things going on. But we have hiker A and hiker B. And one thing I know about hiker A right over here is that hiker A is traveling at 3 miles an hour. So I'll write my rate here equals 3 miles per hour. And then we see over here, hiker B leaves at this time, but travels at this speed, 4 miles per hour. So I'll go ahead and write that down as well. So now that we have those two rates, it's time to determine the time for each of these hikers. And then from there, what's really important is, well, what do we do with those distances once we actually calculate them individually? What are we going to do once we actually have those individual distances? And that's going to be given away right over here. Same direction. When we have objects that are moving in the same direction, what we must do to get how far apart they actually are, what we must do is we must cancel out where they actually overlap. And that is going to look like subtraction. So all we need for this is to figure out the time that each is traveling for. And so when we see that we are measuring at 12 p.m., hiker A starts at 6. From 6 a.m. to noon, that's going to be 6 hours. So I'll go ahead and write 6 hours over here. And then when we think about for hiker B, 9 a.m. to noon, that's going to be 3 hours. So now that we have the rate and the time for each of these individuals, we can calculate those distances, which distance here equals 3 times 6, and that's going to be 18 miles. Then for hiker B, we have that distance being 4 times 3, and that'll be 12 miles. So now that we have those distances individually, we'll subtract to get that final distance apart. So that'll be 18 minus 12, and that'll give us 6 miles. And there we are. Our correct final answer, my party people, is going to be C, 6 miles. And let's take care of this problem here. So the question sentence reads, how long does the jog take? Okay, so let's highlight that question sentence. And we see that it says, how long? How long does this thing take? How long does the jog take? Well, that's telling me that we're looking for a time period. We're looking for how long something takes. That is time. So I'm going to write that down right there. I am looking for time. Now from here, I see that the information that I'm given is 9.6 miles. That is my distance. And then I see 6 miles per hour, and that is a rate. So notice that I have distance, I have rate, and I'm looking for time. So with that said, hey, I'm going to set up my formula, distance equals rate times time. And remember, the most important thing is to fill in the information in the right places. So we have distance right there, so that's 9.6. We have the rate over here, so that'll be 6 miles an hour. And we multiply that by time, and there we go. So from here, what we're going to do is notice that we are looking for time. So we're not multiplying forward to get distance. We're working backwards to get time by itself. And that means that we're going to divide. So we are going to divide both sides by the 6, just like that, to get that 6 out of the way on the right side. And now all we have to do is divide 9.6 by 6. Now, if this isn't obvious to you, don't worry, it's not obvious to a lot of people working with decimals here. So let's just go ahead and divide 6 going into 9.6, and then we'll see what the answer is. We'll put in the decimal place in that quotient, so we have it lined up nice and easy. And now we'll divide. 6 goes into 9 just once, and then we're going to subtract 1 times 6, which is 6. We have 3 as the remainder, but we're not done. We're going to drop the 6 down right here, and now we have 6 going into 36. How many times does 6 go into 36? Yeah, that'll be 6 times, and there we are. Boom, all done. Our final answer here, the correct answer, is going to be 1.6 hours. And that is answer choice A.